Welcome back to Webinar Wednesdays, and this is brought to you by the Beckhoff USA product and marketing teams. I am Brandon Stifler, the US Software Product Manager. I'm back again for round number 3 for me, actually, and today we are talking about TwinCAT Analytics. Now, this is a relatively new offering from Beckhoff, and its intent is to capture basically the whole analysis workflow. And that's from data acquisition down on the device through analysis or post-processing tools, all the way to front-end interfaces, so front-end dashboard interfaces. So that sounds like a lot. It is a lot. So let's get right into it. All right, what we're seeing here is like the big picture, and it's both an architectural diagram and a product outline. It shows how everything kind of fits together. But I know this is a lot on its own to look at all at once. And that's because this is a whole product family. There's several different components and they're all sort of working together toward a complete data solution. That's really what we're trying to accomplish. So what we call TwinCAT Analytics is a collection of cohesive tools that address acquisition, analysis, and visualization of data from our automated systems. However, we're also going to find out it's not necessarily like a full send, all or nothing type deal. Most of these components are not super tightly coupled, so you can potentially piece together a solution that fits the needs of your application. But rather than discussing or dissecting this diagram and digging into the products themselves, I think the best way to cover a topic sort of this broad and fully understand all the moving parts is to talk through like our general approach to solving these data-oriented problems. There's going to be a lot of examples and scenarios, so hopefully you can relate or draw some parallels to your own challenges or your organization's challenges. Then we'll tie it back into the products and their roles and a little bit more specifics on how they work. So getting started, as we know, the data starts here, down on the controllers. Doesn't matter if we're a machine builder, a process systems engineer, a production manager, the bottom line is usually the same. We've got automated systems with PLCs out there, and we want data from them. We want to know what's going on. There's a lot of different ways to accomplish that, but first let's answer the easy question, which is the why. Now, you're listening into a webinar about analytics. You probably already understand the need, but there's countless examples that I kind of like to call out. And again, those are going to vary based on your priorities or your role in the organization. But just to name a few, maybe we want very high speed, high resolution raw data to aid in troubleshooting, in maintenance, or program optimizations. The level of fidelity and accuracy of your data is something we're going to bring up a lot. It's going to keep coming up today because it's really a key differentiator. Having time resolution beyond like the typical 1 second or 500 millisecond polling rates we see from SCADA or MES systems might be a bigger deal than you think. That being said, maybe our priority is just to view or analyze high-level production metrics like the overall equipment effectiveness across an entire production line. Another use case. Or finally, maybe we need to train a data-hungry machine learning model for something like predictive maintenance, data synthesis, or to save the world because it's AI, or maybe just to justify your latest round of funding. The bottom line is access to this data is vital. So the sooner you start collecting it, the better. So step number 1, acquisition, probably the most important part. And foundationally, we need an acquisition solution that's easy to set up, fast, and reliable. So picture just being able to like browse a list of variables or IO points in your PLC program and simply tick a box to enable the logging of their values. From there, the controller can push that data out at some fixed rate. Again, might feel a little bit like the opposite of what many of us are probably familiar with, where those external systems, your MESs, your SCADAs, tend to pull the data out from the device. But there really are some key advantages to that push approach. Once more, speed and accuracy. If that's a priority, I know that producing that data right from the PLC, right from the horse's mouth, synchronized with my deterministic task is going to be advantageous. I also know that if I run into connectivity issues somewhere along the line, I'm immediately aware and I can begin buffering that data locally so nothing is truly lost. And then finally, scalability ends up being easier with this approach as well. Let's look at that. Because in isolation, perhaps this device can write directly to a database or some persistent memory like what we're seeing here. However, ideally, we'll have a solution that's scalable to accommodate logging from multiple devices in a distributed network. So using a sort of hub and spoke communication model will give us a single central source of truth for all that logged data. And whether that's on-prem or online in the cloud should be irrelevant. A single endpoint acting as a broker, and if you know your IoT protocols, you can probably guess which one we're talking about here. It also keeps IT and device configuration very simple. Newly added devices simply point to that same address as all the other ones, and they just start pushing their data. All right, so just switching up the view a little bit here, I still have my devices or my PLCs. They're streaming their real-time data up to this central location. Now let's talk about the storage piece. Our communication model is such that accessing all this data coming from the devices, again, is the easy part. The storage layer just becomes another node connected to that same center entry point and effectively listens for all that stream data as it comes in. But with all this data, we need sort of strategies around what to store, when to store it, exactly where to store it. That's where we probably want to elaborate a little bit because we want maximum flexibility to best leverage all this information. I think the easiest of these three questions to answer is probably the where, because really I just want options, right? Anything from flat files on the local file system to a SQL database, maybe it's somewhere else on the network, maybe it's local, maybe even a time series database like Influx, right? We'll be working largely with time-stamped data. Maybe even CSV files, whatever, just let me choose. Then I can access or query those data sources however the heck I want. Finally, let me configure multiple instances of these stores as well, so I can accommodate any means of consuming this data I see fit. All right, the other two maybe get a little bit trickier. What exactly are we storing and when? Now remember, we just selected some variables on our controller and basically pressed the go button. So while we know what's being sent from the devices themselves, we haven't necessarily defined what's being stored unless we're just assuming it's everything. And while that might be the easiest approach, for obvious reasons, it's usually not the best idea, especially with the high-speed data we've been talking about. On top of taking up a ton of space, that becomes a lot of noise as well. So it makes it a little more difficult to query, to analyze that data when there's just so much of it. So there's a couple solutions to that. One is to just simply control the device stream. For instance, we probably don't care about these values coming from our machine when it's idle or when it's being serviced. So if we can disable or enable that stream right from the device, we can clean up our stores significantly. There's a few more scenarios to think about, though. It might not always be feasible to condition the stream like this, right? We might not have a machine with discrete states. Instead, it might be a continuous, long-running process. Or, and this is quite common, what if the data we need is actually prior to some significant event and we can't reliably anticipate that event? Usually, the most important information would be leading up to that. So if our stream is not active, if it's disabled for any reason, we can end up missing some of that crucial data. So scenarios like that are best addressed with a little bit more intelligence here. Instead of this just being a passive listener that basically stores everything coming in from all the streams, we kind of promote it to a service layer, again, just by adding some intelligence. Now we can both evaluate the incoming data and we can reference the historical data since, again, we're managing all those stores. And it kind of just brings everything together to make those crucial decisions, those what data is stored when and where. So if we revisit that same event scenario, some alarm occurs and we can take, for instance, the last 5 minutes of high resolution data from a short-term buffer and store it in a long-term database to analyze later. After that, you can set up additional rules on how to handle sort of the rest of that data, whether it's recycled in a ring buffer or because you don't need it unless something goes wrong, unless that significant event happens. Or you maybe downsample it by applying aggregate functions, like taking the min-max average of some value every hour, storing it off in another table. Or we can apply other types of rules like thresholds. For instance, retain this value for every second it's outside of these bounds, just all kinds of stuff like that. Basically, this service layer where we can apply these rules to the incoming streams and to the stores gives us the ability to keep exactly the data we're after, nothing more, nothing less. Kind of sounds like our ideal acquisition solution because we could benefit from that high resolution data without any of those drawbacks like noise and storage space. So next up is the actual analysis. Now, up to this point, we've established access to our real-time data. Now, thanks to that service layer we just sort of described, we have access to historical data as well and in just the right amount. And all this information is somewhat contextualized insofar as we know our processes, our machines, we know what sort of data to expect from them, from their controllers. However, to pull out significant or actionable insights, we're likely going to need to perform some analysis. As good as our storage layer is at giving us exactly the data we want, it's still just essentially producing tables of values, which are not usually the easiest to look at and to learn from. So perhaps as an organization, you already have some type of solution, some tooling for this, because tool chains for querying, for analyzing data, those are nothing new. They're well established, they're commonly implemented. And if that gives you everything you're looking for, great, you're off and running. Maybe you just needed a better way to get data from the PLCs. And we've given it to you in your preferred database of choice. I think we got to kind of pump the brakes on that though, because what we usually see is a bit of a disconnect between the OT side and the IT side when it comes to this analysis piece, where these existing tools that might already be implemented are very much tailored to front office type reporting. And they're not especially useful for operations or maintenance or engineering. This is right in line with something we already touched on, which is different roles have different priorities and different needs when it comes to the data. But those high-level reports often lack like a degree of granularity required for those OT priorities, those engineering improvements, the troubleshooting efforts, even things like condition monitoring. Obviously, in the ideal organization, every team has effective analysis tools to leverage that data to improve the business. So from the OT perspective, kind of how do we get there? So we're going to start by just gathering some requirements. First and foremost, the tool is going to have to be comprehensive if it's going to be useful for all our OT personas. There's a lot of hats being worn and a lot of different roles, even just on the OT teams. For instance, one day it might be maintenance team interested in something operational, like the root cause of some alarm that led to all that downtime last shift. Another day it could be more nuanced, like engineering looking to optimize a cell's recovery sequence or improve the line's uptime. Finally, management maybe wants to understand the long-term impact of those optimizations once they're implemented, and that'll help them substantiate the improvements, help with resource utilization, allocations, all that good manager stuff. All those types of scenarios benefit most from a visual tool, right? Because we're doing a lot of comparing data over different time ranges and things like that. And since most of these folks don't typically have a data science background, this breadth of capabilities needs to be approachable. So our final requirement here would be basically a low barrier to entry, something that's relatively easy to use, it's intuitive. I know for sure all these OT folks can write ladder logic, but unfortunately, I don't think that's an option for something like this. That being said, we also don't want to require writing Python or SQL scripts. So given these requirements, basically we end up with a simple yet powerful no-code solution that any one of our OT professionals can simply plug into this architecture and start analyzing. Again, thanks to the push-based hub and spoke communication model, we're just connecting to that same entry point as all the other components, and that gives us access to both the real-time and historical data. Finally, we have a library of building blocks or of functions that we can apply to that data that we can post-process with to create our own analysis. So let's take a closer look at that, see how that might work in practice. So these blocks can be really simple, like foundational instructions. We're talking counters, timers, logical or mathematical operations, and then all the way up to more advanced algorithms like standard deviation, classifiers, histograms, stuff like that. And while that might not sound like much all on its own, if we can chain these blocks together, we can take a handful of even simple operations and very quickly build to a useful output. As an example, we can take a single digital signal, like that alarm from the last scenario. We could take that as input, apply just a few algorithms, maybe a counter, a timer, some sort of accumulator. Now, if we run this against both real time and historical data with a configurable time span, we've given ourselves actually a really powerful expression here. We now know the total number of times this alarm has occurred. We know the amount of time for each instance it was active, and we know the total amount of time it was active because of the accumulator. And that's over the whole time span we've been measuring or within some time window that we specify. So we can get those values for a specific day, week, shift, whatever. So it goes from, man, that one pesky alarm is killing us, to that alarm happened 5 times last shift and it cost us over 20 minutes of production time, 25 minutes of production time. By the way, we're also measuring the time between good parts coming off the line. Gives us an effective parts per minute of 9.6. So that's roughly 238 fewer parts, assuming a rate of 12 reject parts per shift. We're also counting those. So we know that's about average for the past 6 months. Again, all hypothetical, but hopefully you can see the difference there. It's much more impactful when we have real numbers to put behind these situations. Finally, before wrapping up analysis, we can take it just a couple steps further. Let's say we fall in love with this particular chain of blocks, our alarm analysis here, and we want to be able to apply it to all of our alarms instead of just one. Well, we could put on our programming hats and treat these like they're modules. We can pull out just the logic and parameterize the inputs so it becomes a reusable definition that can save time and reduce complexity and errors. It's just really powerful there to be able to basically generate templates. Finally, just to expand on the visual aspect of this environment, it'd be hugely beneficial to be able to render all of this data in charts, in graphs, in histograms, etc., right within the engineering environment. Again, this is primarily time series data coming from our PLCs, which lends itself really well to, for instance, YT charts, where you can see not only the raw incoming data, but also the resulting output data from your analysis blocks. So all of that can be easily viewed and compared together. And that gives us a natural progression to the final piece, which is visualization, or basically the consumption of the analyses that we build in that tool. It's really just kind of the last cherry on top to our solution, an impactful way to visualize all the wonderful things we've built within the analysis tool. While that environment is somewhat graphical in its own right, as we discussed, it's really purpose-built for the development of analytic solutions and not necessarily for viewing the result. So we need a proper front-end interface to the output of those building blocks. And we want to end up with basically a nice-looking dashboard-style view, not unlike what we saw from those front office reports. However, not only are we emphasizing the high-level insights, but we're also enabling that deeper dive for the pertinent OT-focused information. Now, from a technical perspective, ideally this is web-based, so it could be served up to anyone who needs to access it from wherever. But the million-dollar question then becomes, who the heck's going to build this thing? We're about as much web developers as we are data analysts. Now, we pulled off the analyst piece with good tooling, so we're going to need the same here. It's going to need to be just as user-friendly, just as approachable as those simple building blocks. But maybe we can do even one step better for this piece. What if we can automatically generate the view based on the analysis that we've already built out in this tool? And this is actually possible if each one of those building blocks has a corresponding graphical representation. Now we're simply selecting which graphics we want to represent each block or each collection of blocks, and then the view can be generated automatically. From here, it just becomes essentially a deployment process from the analysis development tool to the server of your visualization page. Now that server piece connects directly into the same data sources and effectively becomes the runtime version of the analysis that you've built over here. So it executes each of those blocks, those functions continuously in real time while serving up a nice view to the clients. So that's it. That sort of closes the loop. That's our full data solution. We started down at the device where the data originates with simple push-based logging. We specified a communication strategy that's flexible and scalable and gives you that single entry point for all of our data and all of our tools. And we have a configurable data storage layer that gives us options for, again, what to store, when, and where. And then finally, powerful yet user-friendly analysis building blocks that take the data from numbers in a table to dashboards full of actionable insight. Now, if we rewind all the way back to where we started with the TwinCAT Analytics product diagram, surprise, it might not look too unfamiliar anymore. The architecture, all the principles are the same. And we kind of already discussed the basic mechanisms behind each component and their roles in the whole process. But now we can dig a little bit deeper into some technical details on Beckhoff's specific implementation of this solution. So again, we're starting down here with the analytics logger. Now, if you're using TwinCAT already, good news, this piece is probably already built into your runtime. You would just need to go into your project and enable it. And just as we suggested, like what that looks like, setting up the logger is as simple as ticking some boxes, selecting primarily which variables you want to log here and how frequently. Now, I mentioned a couple times speed as an advantage here. And with Analytics Logger, if we want to, we can tell it to capture these values every single PLC scan. So now you're getting the state of the system exactly as the controller sees it. So it's basically a true snapshot of that point in time down to the PLC task scan. Beckhoff has always been about high speed, so why should our logger be any different? Just again, to kind of harp on the advantages to having that level of granularity, we already mentioned some like program optimizations. If you have the exact state of your program for each PLC scan, you can easily track down race conditions. You can optimize motion profiles, things like that. You can combine this functionality with our measurement tools and oversampling terminals, to realize high performance test and measurement applications. Now, my friend Alec, our test and measurement product manager here in the States, he'll have a lot more to say about that and about those capabilities there. So stay tuned, maybe a collab between us in the future. But essentially, the high-speed logging to match the high-speed performance of the rest of Beckhoff's portfolio is really just a natural union. All right, so for now, this logger works on the controller itself. You have two options. The data points you select are either pushed to a central broker, as we already sort of illustrated in a distributed model, and that information will be sent as a continuous stream over MQTT. Or if this system exists standalone in isolation, you can also log directly to the controller's non-volatile memory. Now, we're primarily PC-based controls, as you know, so this controller typically has a file system, and you have access to that file system. So we can store the data directly as files, and then you can simply pull them off and analyze them with all the downstream tools, or even with our free Scope View product. So even for small non-network applications, and adding to the fact that this is quite an inexpensive tool, the logger on its own can provide a ton of value. And just an example of that, just sitting there and keeping a local ring buffer, like the last 24 hours of pertinent signals in your PLC. If something goes wrong, simply pull those files off, narrow in on the appropriate time frame, and take a look at all those signals and trend them, visualize them. So in that sense, it's often described as like the flight recorder or black box of your control system, which actually I learned through making this that black box is a bit of a misnomer because the thing's actually bright orange. But anyways, next comes the storage piece, and we explained sort of how this works in some depth. But I had previously described it as a service layer, which is accurate, but our name for it is the TwinCAT Analytics storage provider. And basically, it's an application that, again, listens for one or many device streams and handles storing that data to one or many stores. And as we had identified, the key for this piece is flexibility. So the storage provider is very configurable. You can establish connections to multiple streams via multiple brokers, and you could output that data to many different storage types as well, whether that's flat files, SQL database, influx database. I think they even added Postgres as an option, as an output type, or even directly to cloud-based storage. The really cool feature of this product that addresses those tricky requirements that we identified before, those what, where, whens, is what we call the rule engine. And this is where we can build out conditions for storing based on signal values, on thresholds. This is where we can apply aggregate functions to downsample. So this is a snapshot of the actual interface for that product. And again, it's another graphical, easy to use tool, but it's where you identify those rules. So you specify an input source here, you you apply the rules and conditions to that incoming data, and then you generate the resulting output. So this one that we're seeing here just happens to be a time-based sort of hot, warm, cold storage retention policy configuration. And that's pretty typical for data warehousing scenarios, but can be applied right within this tool. Again, really useful when you're dealing with this high fidelity data acquisition. And then finally, we have a little bit more going on up here at the top with our analysis and runtime section. The concept is the same though. We hook into this architecture, we leverage a collection of building blocks to create our analysis. And but we have it broken up into kind of a few different pieces here. Now we'll start with the service tool and take a quick look at just the experience of building out that analysis. So that's this piece here. But I'll preface this section by mentioning that everything we do here, we can also do with the Workbench tool over here. There's really just one small difference between those two tools that I'll highlight in a second. But for the actual engineering environment that we're about to see, they're functionally identical. Now, if you've ever used Beckhoff's Scope tool, you might recognize why we often call the analytics development experience Scope++. Other than the fact that we seem to like that ++ designation, analytics brings us a huge collection of analysis algorithms, those drag and drop building blocks that we can chain together on top of the existing trending capabilities of Scope. Again, the YT trends, the charts are extremely useful in digesting this type of time series data. And that data is almost always being streamed directly from the device or being sort of played back like a stream from those historical acquisitions. So having the visual representations are huge as well. So you can see over here, just breaking down the interface, we have all the algorithms over here on the right. And I believe there's around 100 of those now, maybe a little more than 100. Again, ranging from very simple counters and timers to complex filters, classifiers, even hardware-specific modules. For instance, if you wanted to calculate the energy utilization of one of our AX servo drives, there's just a single drag and drop instruction for that. And that library is always growing as well. So, and then finally, there's even ways to create your own custom algorithms. So in general, each algorithm has inputs on the left, some parameterization or sort of static configuration in the middle, and then outputs on the right. And the output of one algorithm, again, can be chained into the input of the next. So that's how we use those real simple instructions or collection of simple instructions to build a complex analysis. So here it is quickly in action, and this video is sped up quite a bit just for time, but I just want to kind of touch on some of the important parts. I'm going to pause it here. So what we see down below, this is the target browser, and it's pointed at our broker. I know it's a little bit small, but you should be able to see This is pointed at our central broker, so it could bring in all the different devices and then also both the live and historical streams for each one. So all the data is right here once we point to that, again, that central source of truth. You can see we have a handful of devices here. Some we're not given names, so they're just identified with a GUID. Other ones we can give friendly names. So if we have logical ways that we want to break out our architecture, that's totally feasible as well. Get this back going. But then, yeah, basically I bring up that target browser and then I'm able to select a signal from one of those sources and simply drag it up into the input of my algorithms. And that's it. That's how you tie those pieces together. And then from there, I can also quickly bring up a trend view of data coming from those sources. But again, not just coming from the sources themselves, but also I could trend the output of my algorithms and I could put them on the same trend, view them in the same plot to quickly compare, or I could add markers for timestamps of significant events that are captured by my algorithms. Or I can even have several YT charts sort of next to each other in the same view, looking at different data sets over the same time window at once. So again, just really easy to compare the data, to build out your analysis, and just a good illustration of the rapid results you can achieve once you have all your data sources kind of plugged into this. All right, so let's just circle back and differentiate those two pieces. Now, it's somewhat captured in the graphic right here with these arrows. The workbench, again, is that same development environment, but it has the ability to deploy the runtime piece, where, again, each one of my analysis algorithms has a corresponding graphic. And with our one-click dashboard generator from this tool, you can generate a project that both runs the analysis 24/7 and serves up the dashboard. Serves up the dashboard as a web-based interface. And again, I bring back this video because it illustrates this piece really well. We could see each algorithm sort of tied to its graphical counterpart. Even if that's, whether that's a chart, a histogram, or even if it's basic state indicators or value indicators. And that's why we call it a one-click dashboard, because the runtime and visualization pieces are automatically generated based on what you've built in the workbench. And then there's just some examples of what that output can look like once generated and served up as a nice functional dashboard. We have theming and stuff like that. It's just really powerful capabilities. So that's almost the whole picture. There's a couple more little pieces worth talking about. One thing we did not address was if you're using third-party or legacy hardware. Now, not every PLC is going to be equipped with the analytics logger, which is seemingly a foundational component here. But if that is the case, you're using maybe third-party hardware, you do have options. So what we have here is a piece of Beckhoff software called the IoT Data Agent. And what that can do is act as a gateway and convert the OPC UA traffic, for instance, into MQTT to be able to tie into the rest of this workflow. There's also a data exchange API offered in both Python and in .NET, and it provides bidirectional communication with these components. So it can act as a bridge interface as well, similar to this tool, or it can read incoming streams from the devices or from the storage provider if you were, for instance, writing your own custom consuming application. So again, just flexibility, kind of opening it up a little bit. So that is the whole picture. We've kind of gone through, explained each individual product, how they work, why they work the way they do. We also acknowledge that value can be gained with just individual pieces. So we can use just the logger locally to keep a buffer of high-speed data and then offload those files for troubleshooting, either with our free scope tool or with the analysis algorithms provided within those engineering tools. Then you can add in connectivity and then maybe the storage provider to configure dynamic, short and long-term data storage recordings, all to common database formats that are queryable by any third-party tools. Or you can implement the full workflow, go full send, and realize 24/7 analysis with the workbench, with runtime generation, and with dashboards. And that's pretty much it. That's all I have for you today. Hopefully, I've helped you gain a good understanding of the capabilities of the product family, the massive amount of value to OT teams and organizations it can provide, and just sort of a foundational understanding of this particular approach to a data solution, how sort of the capabilities and the design decisions allow for maximum amount of value, of flexibility, of scalability, of user friendliness. All those strengths I've outlined throughout. And with that, we can open it up to Q&A. It's been open the whole time. My team has been helping answer those as they come in, but I'll take a look and try my best to take on a couple live as well. So one that I see, and this is very commonly asked, I get this almost every time I start talking about this product, is what data format does the logger use? And it's kind of two parts, because again, the logger can both write to files or stream over the network. In both cases, it's actually utilizing a sort of somewhat basic run length encoding algorithm, because we're really trying to balance time and space efficiency. So again, when you're storing or sending data at the rates we're looking to achieve, like every millisecond, every 10 milliseconds, we really need to be optimized, but we also can't introduce too much overhead in that process of encoding or of compressing, because we really just don't have the time. We're sending it out so fast. So if you were to dig into the data, either coming from the logger, either by sniffing the messages over the wire or by digging into one of the files created by the logger, it would be encoded. And that's just another function of the storage provider or of the APIs, is to decode that data into human readable formats. So let's see if I could bring up any other questions that haven't already been addressed by the team. Yes, yeah, so like one person asked, what MQTT spec does the logger support? And it's just binary data over the wire there with sort of a proprietary encoding, again, because we need to tightly control, we need to balance the time efficiency and the complexity and the data going over the wire as well, because we're just really trying to maximize for throughput. Yes, one person asked about availability of features. Everything that I've talked about today, with I think the exception of the Python API, is available to use today. All right, we have one here. Real-time data processing can get expensive. What's your recommended approach for managing costs? Yeah, so I think I somewhat captured that conversation while dealing with or talking about the storage provider and just the level of flexibility it gives you when you're bringing the data in, when you're downsampling it. So it gives you opportunities to reduce the cost based on how much storage you're using. So, I mean, we don't offer software as a service necessarily, or storage as a service with this product. You're somewhat on your own for that. We just give you the different options, the different database and file storage types. But yeah, that being said, it's up to you to implement strategies that balance how much storage you want to take up versus how much real-time data you really want to capture. But with that storage provider tool, you have the opportunity to say, keep that really high resolution data for a day, a couple days at a time. And that's the data that's really important for actually troubleshooting from an engineering perspective. And then you could use the downsample data for those high level insights, those front office reports, your dashboards. So it's really just a balancing act, strategy for managing that data. Let's see. So TwinCAT Analytics Workbench, different from TwinCAT 3 engineering. So the Analytics Workbench is a component of sort of the whole TwinCAT 3 engineering environment. It works within that same Visual Studio shell-based environment, though. So you just install that as a separate package or as a separate component, and then you can create analytics projects right alongside your PLC HMI projects. It can all be within the same solution. Let's see, looking for more unanswered ones. Can you save the analytics tool to GitHub for version control like everything else? So yes, as you build out a analytics project, all those algorithms, and as you tie them together, that is all text-based as well. Similar to our PLC projects and whatnot, there's like some XML metadata, some wrapping around these instructions so that we can accurately render them and make the projects portable. But it is version control available. If you clone a active project that's been pushed, you will be able to open it, you will be able to modify it, etc. Okay, let's see. Most of the other ones. Okay, so here's one. I'm currently using Elasticsearch as my time series database. Does the storage provider offer an adapter for it? Unfortunately not. We don't use any sort of cloud, any provider specific databases. We kind of wanted to keep it open. So we currently support, again, Influx time series database. We support Microsoft SQL Server, and I believe we just added an adapter for PostgreSQL as well. On top of, we offer Azure Blob, so direct writes to Azure Blob storage. You could save it right in the binary format that it's coming over the wire in, or you can also save it to CSV files. How much of this can be done with the 7-day license? Really good question. So from the runtime perspective, from the IoT data agent, those are TF functions. You have the full functionality with your 7-day license. The engineering tools are another story. Now you can actually use, for instance, the service tool or the workbench with a 7-day trial. Those are engineering environments though, so they're going to be limited. So what you can do is activate the 7-day trial license, and then you can create a new analytics solution. You can drag in algorithms, but you'll be limited to the amount of algorithms that you're able to drag in there. Eventually, it's going to say, "Hey, your trial's up. You either need to purchase a license or contact the team, and we're usually able to work with you. We can give you demos. We can help you design your analysis if you're sort of on the fence about making a decision." So yeah, just reach out to us if that trial is not enough to kind of push you over the edge to making a decision. So once you buy any of these products for one machine, can you use it for more machines, or do you have to buy each per machine? Excellent question. So the runtime components, and I'm just going to back up in my thing here so I have my diagram again. I'm going to try anyways. Okay, perfect. So the runtime components, like the analytics logger, that lives on the controller on the machine. So for every machine, you're going to need an instance of that license. Now, that is also the lowest cost component of this whole picture. It's really low cost sort of adder license. And again, it's typically already installed with your TwinCAT runtime. It's just a matter of enabling it, ticking those boxes to select which signals you want to log. The rest of these components, like the IoT data agent for bridging, the storage provider, the engineering tools, those are designed to work with multiple devices. So you can have a storage provider that's aggregating data from several different devices. Now, if you are pushing tons of data from every single device, you might need to build out an architecture that's scalable, that utilizes multiple instances of MQTT message brokers, of storage providers. And that's not uncommon at all, but they're all designed to work with multiple controllers. So if, for instance, just hypothetical, you have between 5 and 10 controllers, you could very easily realize that configuration with a single broker and a single instance of the storage provider. And then, of course, the engineering tools, you're just buying a license to use. So what we typically see with the workbench or the service tool is you'll buy a license that lives on a dongle. And then you can pass that dongle around to your team members, and anyone could use the tool, can refine your analytics product as long as you have that license. Got one here. For a standalone machine, if the data gets saved locally in the IPC, is there any sort of purge service to prevent taking up the space from the hard drive? Also, really good question. The typical approach here, there's two really, is you can log in perpetuity, but obviously you're going to run out of disk space eventually. So the typical strategy there and the easiest one to configure is just a ring buffer. So if you say, hey, log all these values, keep them for 7 days, and once you roll over the 24th hour of that 7 day, it just starts overwriting the oldest information. So you always have a 7 day window, the past 7 days worth of data, and it's a moving ring buffer. It has a fixed size, so it never goes beyond a certain size and crushes your disk. Great question. How well do these tools work with 4026? Also a great question, and a very pertinent one, because the engineering environment for 4026 was one of the later components to be ported, but it is now available. So I don't think that there's any single component of this that is version exclusive. It should work with both 4024 and 4026. All right, can control be implemented in the analytics tools for real-time system control or a part of the auto HMI generation tool? So yeah, so let me, I'm not sure if this will answer your question, but I can elaborate a little bit more on the real-time component. So what you're actually generating out of this workbench is a PLC and an HMI project. And then those are what run sort of continuously to give you your 24/7 analysis and to serve up your dashboard. It's just a PLC and HMI project. So that being said, though, you have access to those projects. So you can add logic onto them. You could modify them. You could modify the HMI and add your own custom graphics. Now, that's not always a great workflow, because again, we're dealing with code generation here. Typically you want to work within this engineering environment. That way, when you generate a new version, it's not overwriting a bunch of changes that you custom made to this runtime. But it is possible because they're just PLC and HMI projects. In that picture, where does the storage provider license reside? So wherever the storage provider service runs. So again, this is just an application. So it could conceivably run, in the cloud. It can run on one of the edge devices. The only requirement for this application is that it has connectivity into this broker. Let's see, anything else? Can you send the presentation diagrams? Yes. That one looks like it's already been taken care of. See if there's anything else. Okay, here's another good question. How do I transform the logger formatting to a generic MQTT client? So let's say I have messages coming out of here in that logger format, that run length encoded format that I was already talking about. How do I transform that into maybe a human readable stream, right? An unencoded stream. Again, you can do that. The storage provider as an application does that. That's sort of one of its purposes. And then it stores it in whatever format you want, the ones that I listed before, the SQL, Influx, CSV, etc. Or you can leverage the, let's see if I can bring that back up, or you can leverage that API, the data API, which would run, again, as like a standalone service on whatever piece of hardware, again, as long as it has access to this broker. And it could dissect that feed coming in, or those multiple feeds, and present it to you as a generic stream that you could do whatever you want with. And again, that's available in Python or in .NET. And okay, yep, storage provider would naturally not reside on a PC, rather a server. Does the licensing model? Yes. So the licensing model for the storage provider is the same as all of our other runtime components. So really good question there. It's kind of an unfortunate answer because it is more expensive to run that on non-Beckhoff hardware, but that is unfortunately the case. That being said, I don't think that that component is particularly expensive, but yeah, we can talk about that in the future. Feel free to reach out. Yep, and video recording will be distributed after the fact for anyone that attended or signed up and wasn't able to attend. All right, so I think I'm going to wrap it up now. I don't see questions coming in at the rate that they were. Looks like we covered most of it. So just some closing thoughts. Once again, I am Brandon Stifler at Beckhoff USA. If you would like to learn more, feel free to reach out to me or your local Beckhoff representative. On the screen, you see these QR codes. There's contact forms, and the other one is information on upcoming episodes in the Webinar Wednesday series. Now, next up, my team member, Brandon Snell, other Brandon I like to call him, will be talking about our brand new MX product line, MX system. And that's essentially a game changer for realizing that cabinetless automation or control systems. Pretty exciting there. Be sure to tune in for that one. Finally, I'll be at Automate next month in the Beckhoff booth. We'll be front and center, easy to find, can't miss it. So come see me if you want to chat about this stuff, about any other automation related topics. But yeah, I very much appreciate everyone's time today. Thank you for tuning in. Again, any more questions, feel free to reach out.